In this class, we will discuss about remaining questions of Chapter 1, Exercise 1.3. In the Exercise 1.3, we completed question 1 to question 4. Now, remaining questions I am taking in this class, question 5 to question 9. First, I am taking question number 9. What is the question number 9? Observe. Classify the following numbers as rational or irrational. We want to classify rational or irrational. We already discussed about the rational numbers and irrational numbers. So what about the rational numbers? Rational numbers are expressed in the form of P upon Q, where PQ are integers and Q should not be equal to 0. First one. This is the definition. Second point is that all integers, what are the integers? Counting numbers, 0 and negatives of the counting numbers. All integers are rational number. Now third one is what? Terminating decimal expansion. What about the terminating? Terminating means if we are having 1 upon 2 and once we solve this one we are getting 0.5. So 0.5 in the terminating we are having remainder 0. So if numbers are terminating decimal expansion called rational numbers. And next one condition is what? Non-terminating. In the non-terminating remainder will never 0. So in the non-terminating repeating, if numbers decimal expansion are non-terminating repeating, then we can say that number is rational number. So once we know these all things I discussed in the introduction class, you observe from these points from the introduction class and you can gain something. So this question is based upon if we know well about the rational number, without solving we can give the response of each and every question linked to this one. Now first question, this one. This is the square root of 23 and 23 is what? Prime numbers. I discussed if prime numbers square root and that number is what? What? Rational or irrational? Irrational number. Like this, root 2, root 3, root 5 and so on. Prime numbers square root and prime numbers square root is what? Irrational number. Clear? जो नंबर रेशनल नहीं होंगे वो हमारे irrational numbers कहलाएंगे. Irrational numbers cannot be expressed in the form of P upon Q, and another way we can say irrational numbers are non-terminating, non-repeating. It means what? After point in the decimal expansion, after point we are getting different values up to infinity. In the this is the non-terminating, so remainder will never be 0. So after point we are getting different digits, numbers up to infinity. So that one will be what? Irrational. Second one is what? Irrational numbers are prime numbers square root. Square root of prime number. We can say prime numbers square root will be what? Irrational number. So this one is rational or irrational? This one is irrational. Why? Because 23 is a prime number. So this is the irrational. So in a short I can write there, this is the irrational. Irrational. So root 23 I am writing there. Root 23 is what? Root 23. It is the square root of 23. 23 is the prime number. So it will be what? Irrational number. Irrational. This one is irrational. Now next one. Next one I am taking root of. This is the first one. Second one I am taking root of 225. Once we solve this square root, then what we are getting? Its root. Root of 2 to 5 is 15. And 15 is what? We are getting perfect square. 15 square is the 2 to 5. Perfect square we are having. So we can say, and 15 is what? 15 is the integer, and all integers are rational number. All integers are rational number. So this one is rational. Getting or not? What we are doing? We are classifying rational and irrational. So for the rational, can be expressed in the P upon Q. All integers are rational. So this one, its result, square root of 2 to 5 is the 15, and 15 is the integer, and integer is what? All integers are rational. So this square root of 2 to 5 will be rational number. And square root of 23, 23 is the prime number, and prime numbers square root will be what? Irrational. Clear? Now next one question I am taking there. Next one is what? 0.3796. After 6 we are not having dot. If after in a decimal we are not having dot, then we can say that number is terminating decimal expansion. There is not dot dot, so what we can say? This is the terminating, and terminating decimal expansion are what? Rational number. This is the terminating. This is the terminating decimal expansion. This is the terminating decimal expansion. And terminating decimal expansion are rational number. Rational. Terminating decimal numbers are what? Rational. So first one is the irrational. Why? Prime number square root is what? Irrational. This is the what? After solving square root we are getting 15, and 15 is the integer. All integers are rational. All integers are what? Rational. Now this one is what? In a decimal we are not having dot dot, so this is the terminating, and terminating decimal expansion are what? Rational number. Now next one. In the next question, question number 4th one. Question number 4th one is what I am taking there. Question number 4th one. What is the question? 7.478478 and so on. Question number 4. 9th, 4th one I am taking 7.478478. Now in this decimal expansion, this is the decimal expansion. So in this number we are getting repeating block. 7.478 is going to be repeat. 478, 478, 478. This block is repeating, and once after point we are getting repeating block, that is called what? Non-terminating repeating. Non-terminating repeating are what? Rational number. Rational number. So this one is what? Rational number. So in the question number 9, 4th one is the rational. Why this one is the rational? Because in which we are getting repeating block, and once we are having repeating block in the decimal expansion, and that is called non-terminating repeating or rational number. Now last one, this one. 1.1010010001000 and 1 and so on. This is a decimal number, and in which after point we are getting different numbers. This is not a repeating. So after point we are getting different numbers. Then that is what? Non-terminating, non-repeating. This one is non-terminating. This one is non-terminating, non-repeating. And non-terminating, non-repeating is what? This is the non-terminating, non-repeating. What I am saying? I am taking question number 5th one of 9th. 1.10100, again 130, and so on. So this, there is no repetition, and it is going to dot dot is there. It is non-terminating. and repetition is not there, then what will be there? Non-repeating. So non-terminating, non-repeating is what? Rational or irrational? Irrational. This is the irrational. This is the irrational number. So in this way we solved question number 9th, all questions in which we want to classify rational and irrational. I am revising. In the rational number expressed P upon Q form, P, Q are integers, Q should not be equal to 0. First one. Second one, rational numbers are what? All integers are rational numbers. For counting numbers, 0 and negatives of the counting numbers, they all are rational. Third one, terminating decimal expansion like this. Terminating decimal expansion are what? Rational. Next one, non-terminating repeating numbers are what? Rational. But irrational number are what? Non-terminating, non-repeating are irrational. And prime numbers, square root of the prime numbers are what? Irrational. So I hope you are getting these all concepts linked to rational and irrational. If we know these points, then we can easily to identify rational and irrational. Now I am taking question number 5. Now what about the question number 5? Observe, in the question number 5, what can the maximum number of digits be in the repeating block of digit in the decimal expansion? What can the repeating blocks of digits in the decimal expansion of this one? One number is given, one fraction we are having, 1 upon 17. What will be its repeating block? What will be its repeating block in the decimal expansion we want? Then perform the division to check your answer. So we want 1 by 17. What will be the solution? 1 by 17. Once we divide, we are getting decimal expansion, and in the decimal expansion, how many digits are repeating in the repeating block? So we want divide, its division, or we will use long division method. So 1 is the numerator and numerator is what? Dividend, and this is the denominator and denominator is what? Divisor. So we will use 1 there, and we are dividing 1 from 17. So 1 is smaller. This 1 is smaller than this one, so we cannot divide. So we will use 0 point something. What we will use? 0 point something. 0 point something. Why? Because we cannot divide 1. So we use point. 0 point. We are using point there. So we will use 1 0 there. We used 1 0. We are having now 10. But again 10 is smaller than 17. We cannot divide 10. It is not going one time. So we will use, or we require 1 0. We put 1 0 there. So once we put 1 0 there, it means we should put 1 0 there. Why? Because this point authorized only 1 0. We cannot use more than 1 0 at a time. So this authority we used. So from this point we used 0, but we require 1 0. So we put 0 there, and we can use 1 0 there. Now this is the 100, and how many times it is going? Once we divide from 17, so it is going 8, 17 5 ja, 17 5 ja, 17 5 ja 85. 5 times it is going, we are putting 5 there, 85 there. What is the remainder? Remainder is 15. Now again it is smaller, we require 1 0, but point is there, so we can use 0 directly. 150. Now how many times it is going? 8 times. 17 8 ja, 17 8 ja 136. 17 8 ja 136. Remainder is 14. Again it is smaller than this one, so we require 1 0. So we use 1 0. 140. Now how many times it is going? Again 8 times it is going, and 17 8 ja 136. Now what is the remaining? 4 is the remainder. Now point is there, so we can use 1 0. Now 40. Now how many times it is going? 2 times. 17 2 ja what? 34. And remainder is what? 6. Point is there, we can use 1 0 there. How many times it is going? 3 times. 17 3 ja 51. What is the remainder? 9 is remainder. Point is there, so we can use 1 0. 90. How many times it is going? 5 times. 85. What is the remainder? 5. Again we can use 1 0. 50. How many times it is going? 2 times. 34. Remainder is 16. We can use 1 0. 160. So 160, how many times it is going? 160. How many times it is going? How many times? 153 we want. So 153, it means it is going 9 times. 17 9 ja 150. We are subtracting 160 minus 153 will be the 7. Again 7 is smaller than this one, so we require 0. Point is there, we can use 0. 70. How many times it is going? 4 times. 17 4 ja 68. 68 4 times it is going. Now remainder is 2. Point is there, so we use 0. 20. How many times it is going? 1 time. 17. What is the remaining? 3 is remaining. Remainder is 3. So we cannot divide, so we require 1 0. Point is there, we use 1 0 there. How many times going? It is going 1 time only, because if you multiply by 2, 17 2 ja what? 34, and 34 is more than this one. We cannot divide 2 times. 1 time it is going. So 17, remainder is 13, and 13 is smaller than this one. We require 1 0. 130. Then it is going how many times? 17 7 ja 17 7 ja what? 119. 7 times it is going. 119. Remainder is 11. 11 is smaller than this one. We require 0. So 110. Now how many times it is going? 7 6 ja. 7 6 ja is what? 7 6 ja is 102. 102. Now subtract this one. 8 is remainder. We cannot divide, so we require 0. We use 0. How many times it is going now? 4 times. 17 4 ja 68. Now subtract this one. We getting remainder 12. 12 is smaller than this one. We require 1 0. We put 1 0 there. 120. How many times it is going? 7 times, and 119, and we are getting 1. After this one, now we are having 1. We started from the 1. Yes or no? We started this division from the 1 after 16 digits. After 16 digits. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. After 16 digits, again we are getting 1. It means after this one, again we will follow the same process, and this process is going to be repeated. After this one, we are getting again 6 digit, then 16 digit, then 16 digit, so on. So 1 upon 17, in which after point 16 digits blocks we are getting. 16 after point 16 digits block is there, and then it is repeating. So we can say, what can the maximum number of digits be in the repeating block? In the repeating block we are having 16. So 1 upon 17 is what? In which we are having repeating block, and the repeating block we are having 16 digit. How many digits we are having? 16 digit. And so we can say this one is what? Rational or irrational? Rational number. 1 upon 17, in which 17 digits numbers are repeating. 17 digits numbers block digits block is going to be repeat. So we are getting non-terminating, non-repeating. So we can say, we can use bar on 16 digits. So this will be the answer. This is non-terminating, repeating. Clear? In the repeating block we are having 16 digit. Now next question I am taking. What is the next question? Look at several examples of rational numbers. Look at several examples of rational numbers in the form P upon Q, where PQ are integers with no common factor. With no common factor other than 1, and having terminating decimal expansion. Listen. We want several examples. What we want? we want several examples. Look at several examples of rational numbers in the form P upon Q. There are some several examples. 1 by 2, 1 by 4, 3 by 4, 3 by 2, 7 by 2, 19 by 20, 36 by 25. We are having several examples there. Observe these examples. They are following this condition or not. What required? Several examples of rational numbers in the form of P upon Q, where P and Q are integers with no common factor. P and Q are integers. P upon Q are integers. In the there should be integers. Okay, 1 and 2, 1 by 4, 3, 4, 3, 2, 7, 2, 19, 20, 36, 25. These all are the integers. And these integers, what? Integers with no common factor. इनका कोई कॉमन फैक्टर नहीं होना चाहिए. It means what? No common factors other than 1. Whatever numbers we are using at P and Q, once we do the factors of these numbers, factors having what? No common factor. It means we should use what? Prime numbers. Once we use prime numbers at the place of P and Q, then there will be the no common factor. But 4 is not prime, but we are using. In the 1 and 2, listen, in the 1 and 2, two numbers, two integers are there, but one is a prime, one is an integer, 2 is an integer. What are the factors of 1? One is having only one factor, but 2 are having 1 and 2. But there is any common one? No one. 1 and 4, in these two numbers, again we are having no common one. 3 and 4. Observe these questions carefully. What is happening? What is happening in these questions? Listen. 3 and 4 is the one example, and following 3 and 4, look at the several examples of rational numbers in the form of P upon Q, where PQ are integers with no common factors. I am having one example, 3 upon 4, it is a P upon Q, and PQ are integers. Now PQ are integers with no common factor. I want to check both numbers are having common factor or not. So what is the common factors of 3? 3 into 1. Factors of 4? 2 into 2 into 1. There is no common one. It means both are having what? No common factor. So we can say 3 by 4. Both are integers. What? Where P and Q are integers with no common factor. So 3 and 4 are integers and both are having no common factor and having terminating decimal. We cannot use any number. That number should be the terminating. Once we divide, we solve, we are getting 0.75. And 0.75 is what? Terminating. Observe. हमें वो एग्जाम्पल चाहिए जिनके अंदर ये दोनों नंबर्स इंटीजर्स हो, दोनों नंबर्स का कोई कॉमन फैक्टर नहीं हो, और उनका जो रिजल्ट आए वो क्या हो? टर्मिनेट डेसिमल एक्सपेंशन होना चाहिए. सो ऑल थ्री कंडीशंस. व्हाट ऑल थ्री कंडीशंस? फर्स्ट वन, इंटीजर्स होने चाहिए. सेकंड वन, नो कॉमन फैक्टर होना चाहिए. एंड थर्ड वन, नो कॉमन फैक्टर अदर देन वन. वन हो सकता है कॉमन फैक्टर. नथिंग इज कॉमन, देन वी आर सेइंग व्हाट? वन इज द कॉमन. सो नो कॉमन फैक्टर एंड थर्ड वही व्हाट? टर्मिनेटिंग होना चाहिए. तो हमें ऐसे कुछ एग्जांपल्स की बात करनी है जिनमें P एंड Q इंटीजर्स होना चाहिए, दोनों का कोई कॉमन फैक्टर नहीं होना चाहिए अदर देन वन, और उनका रिजल्ट क्या होना चाहिए? टर्मिनेटिंग. सो 1 and 2, this is the terminating, result is 0.5. 1 by 4, it is the terminating, 0.25. 3 upon 4 terminating what? Terminating result is what? 0.75. 3 upon 2, it is also terminating, result is 1.5. And like I am writing 1 by 2, result is 0.5. 1 by 4, result is what? 0.25. 3 by 4, result is 0.75. 3 by 2, result is 1.5. And 7 by 2, result is what? 3.5. So these all are examples of terminating decimal expansion, and P and Q are integers, and PQ are not having any common factor other than 1. Once we talk this one 7 2, once we factorize we are having no one common. Do this, there is also same, no is common other than 1. In a 3 4 we observed this one already. In both we are having no common factor other than 1. Now what about 19 and 20? Once we do 19 upon 20, once we do the factor 19, we are having 19 into 1. In 20, 2 into 2 into 5. In the 20, we are having 2 into 2 into 5. So there is any common? No one. In 19 upon 20, we are having no common factor other than 0. No common factor other than 0. So not 0. In the 19 upon 20, no common factor other than 1. 1 is the common, but other is not common. 19 is there, there is not 90. 2 is there, there is not 2. 5 is there, there is not 5. So only 1 is common. So this is the example of this question. Now 36 by, what about this 36 by 25? This can be written as 2 into 2 into 2 into 2. 2 2 ja 4, 4 2 ja 8, 8 2 ja 16, 16 2 ja. Possible hai? Do the prime factorization. 36, do the prime factorization. How many times? 18 times. How many times? 9 times. Now 3. How many times? 3 times. Now use 3. How many times? This one. So this will be what? What are the factors? 2 2 ja 4, 4 3 ja 12, or 12 3 ja 36. 2 into 2 into 3 into 3. They are the factors. And what about this one? 5 into 5. In 36 and 25, two integers, both are having any common factor? No one. These are the factors of 36, and 5 into 5 are the factors of what? 25. And both we are having no common factor. And once we solving, we are getting terminating or not. So we want the first check terminating or not. So I am taking there 19 upon 20. 19 upon 20, once we divide, this will be the terminating or not. Without dividing, we can find its termination. If this number is multiplied by 5 upon 5, this number, I don't want to do long division, I am directly want to result. So this number 19 upon 20, I am multiplying 5 upon 5. By multiplying and divide this number to 5, the original number is unordered. Then multiply this one. 19 5 ja. What is 19 5 ja? 95. 19 5 ja 95, and 25 ja 100. And if denominator is having what? Decimal form. Denominator, so not decimal, denominator is the multiple of 10, then we can use directly point there. 2 zeros are there, we remove both and we will put point there from the right. So this result will be 0.95. So without division, we are converting 19 by 20 into the decimal form. How? We are multiplying and dividing by dividing this number by the same number. And what number we are using? 5, because we want 10 multiple in a denominator. So if we do multiplication of 20 to 5, then we are getting 100, and without division we can getting terminating. So we can say 19 upon 20 is the one example, and it is having terminating decimal expansion. 19 and 20 both are integers and they are having no common factor. How? 19 equal to 19 into 1 and 20 equal to 2 into 2 into 5. And finally 36 upon this one. Again I am using same process. 36 upon 25 will be multiplied by 4. Then this one will be what? 6 4 ja 4 2. 4 3 ja 12, 12 and 2 14. 6 4 ja 24. 4 will be there, 2 is remaining. 4 3 ja 12, 12 plus 2 14. Divided of 25 4 ja 100. So we will use point there. We are getting 1.44. This is the terminating. So by solving, we can use division also. Once we divide, we are getting the same answer. I am doing directly because this is also important process. So by doing directly division, we are getting terminating decimal expansion. In which terminating decimal expansion? These all are terminating decimal expansion. So what is the question? Look at several examples of rational numbers. We are having several examples of the rational number. But rational number कैसा होना चाहिए? Where PQ are integers. We are having all integers. With no common factor other than 1. जो इनके जो P and Q है, इनके जो factors बन रहे हैं, उनमें कोई common नहीं होना चाहिए other than 1. 1 को छोड़कर कोई कॉमन नहीं होना चाहिए. एंड रिजल्ट इट्स डेसिमल एक्सपेंशन शुड बी व्हाट? टर्मिनेटिंग होना चाहिए. ऐसे तो बहुत सारे नंबर बन जाएंगे, लेकिन उनका रिजल्ट कैसा होना चाहिए? टर्मिनेटिंग. सो वी आर हैविंग दीज ऑल आर टर्मिनेटिंग. क्लियर? नाउ लास्ट वन. कैन यू गेस व्हाट प्रॉपर्टी मस्ट सेटिस्फाई? कैन यू गेस व्हाट प्रॉपर्टी? इन दीज क्वेश्चंस वी आर हैविंग denominators 2 4 4 2 2 20 and 25, and in denominators are in the form of 2 power m into 5 power n. So what we are guessing there, in the denominators we are having multiple of 2, we are having multiple of 2, we are having multiple of 5. Denominators we are having multiple of 2. In the denominators we are having multiple of 5. And in the denominators we are having 2 and 5 factors. No other factors we are having. So from this observation we can say what? If numbers are rationals and they are no common factor other than 1 and terminating decimal expansion, then their denominators having 2 power m or 5 power n or both. So this is the solution of this question. Now I am taking question number 8th one. What is the question 8th? Observe. I am going to solve there. What is question 8? Question 8 is that what we want in this question, find three different what? Three different irrational numbers. We want three different irrational numbers between the rational numbers, between two rational numbers. Two rational numbers are given. In between we want three irrational numbers. What are the two rational numbers? 5 upon 7 and 9 upon 11. Two rational numbers we are having. In between we want three irrational numbers. In the exercise 1.1 we discussed irrational numbers, not irrational number. Rational numbers between two integers. We discussed rational number between two integers. Rational numbers between two, how many? We find 5 or 6 rational numbers between 1 and 2, and 1 by 4 and 1 by 2, like this. Question we used in between two rationals. We want rational in the exercise 1.1, but this question is showing what? Find three different irrational. We want irrational numbers, not rational numbers. In this question, in these questions, in the exercise 1.1, we find what? Rational numbers in between two rationals. But in this two rationals, we want three irrationals. In between we want irrational. In between we are having so irrational numbers. So easy. For solving this question, first we do the division, normal division. 5 divided by 7. Smaller than this one, how many times it is going? 0 point something. Point is there, we will use 1 0 there. How many times it is going? 7 times. 49. 1 is remainder. Point is there, so we will use 1 0. How many times? 1 time. 7 is there. 3 is remainder. Point is there, so we will use 1 0. How many times it is going? 4 times. 7 4s are 28. 2 is remainder. We cannot divide this one, so we will use 1 0. Point is there, so we can use 1 0. How many times? 2 times. Now, what is the 7 2s are 14. 6 is remainder. We cannot divide. This is smaller than this one. We require 0, so we use 1 0 there. How many times? 8 times. 7 8 is 56. Now 4 is remaining. Now point is there, we can use 1 0. How many times it is going? 5 times. So there is a 35 and 5 is remainder. After this one, again we will follow this process. Why? Because there is a 5. We started with from 5. यहाँ पे हमारे पास 5 था. We dividing 5 by 7. Again we are getting 5. So we will follow same process there. So this, after this one, we are getting 7 1 4 2 7 1 4 2 4 2 8 5 and so on. It means 0.714285. This is a rational number already given in the question. Find the three irrational between two rational. So this is the rational. Now second is this one. Divide this one. 9 to 11. We are dividing 9 from 11. How many times it is going? 0 point. Point will be there. How many times it is going? 8 times. 88. 2 is remainder. Point is there. We can use 0 there. How many times it is going? 1 time. 11. Remainder is 9. Point is there. We will use 0. How many times it is going? 8 times. Remainder is what? Remainder is 2. Point is there. We can use 1 0. How many times? 1 times. 11. Again we are getting 9. Again we are getting what? 9. And this process is going on so on. So in this question we are getting 0.81. After 2 digit we are repeating. So in which we are having 2 digit repeating block. But in which how many digits repeating block we are having? 6 digits repeating block we are having. In between both are rational number. In between we want irrational number. So we can write like this. We are having 0.7142 0.7142 and so on, and 0.8181 so on, like this. Complete, if you want you can write 6 digits 714285 and so on, and use this one like this 6 digit. In between 0.71 to 0.81 we are so many irrational number. First 0.72 3567 so on. Second 0.73 8269 so on. Third number 0.802897 and so on. These all numbers are in between 0.71 and 0.81. Yes or no? 0.72 more than this one, less than this one. 0.73 more than this one, less than this one. 0.80 more than this one, less than of this one. So we require only 3, so we are writing there. If we require more than 3 we can write. Because we are having so many numbers in between. So for finding of the irrational numbers between two rational, first do the division and write as you wish required numbers there. There we want only 3, so we are writing this 3. We can write so many numbers but not used. So in between two rational, how we will find irrational? First do the long division result, and in the results we write 3 numbers. By using the results, in between we will write 3 numbers. This will be the process of finding 3 irrational numbers between 2 rational numbers. Now one question is remaining. What is the question? What is the question? Write 3, question number 7. Write 3 numbers whose decimal expansions are non-terminating, non-repeating. Recurring means non-repeating. Non-terminating, non-repeating numbers are what? Irrational number. And irrational numbers, how we will write? Observe. These 3 are the examples. We want 3. Write 3 numbers. So you can write these 3 numbers there. Why? Because they all are the non-terminating, non-repeating. In between we are find what? Irrational. So these all are the examples of these questions. But I am taking another one. 3. What is the question number 7? We want 3 irrational numbers. What sort of the numbers we require? Non-terminating, non-repeating. Non-terminating, non-repeating. Repeating is also called what? Recur. So we are having so many examples. What? 1.414, so on, like this. 3.1415, so on. Now next one, we can write 7.6057226 and so on. So these are the what? Non-terminating, non-repeating, means after point we are getting different values up to infinity. If we are having like this, then we can say those numbers are non-terminating, non-repeating. In this way we complete these all questions. In the exercise 1.3 we are having 9 questions. In this class we discussed about question number 5 to 9, and remaining 1 to 4 we already discussed in another class. So I hope you are getting lot of ideas and understanding these all questions in easy methods and getting knowledge also. So last I am saying you will revise this class and you will get more and more knowledge. That's all about this class. Thank you so much.